Hello friends, welcome back to my channel where we will be learning about software development lifecycle. This is a complete beginner course for someone who has just introduced themselves to software development lifecycle. With this series of course, we will help you understand what is software development lifecycle for someone who has complete no idea about it. The things that we will learn today is the introduction to software development lifecycle, the definition, the importance, and most importantly, the objectives of software development lifecycle. The software development lifecycle is systematic process used by software developers to design, develop, test, and deploy software. You can think of it as a steps that guides the creation of software from start to finish, just like a recipe that guides you through cooking a meal. Similarly, here SDLC guides developers through the process of building software. There are total 6 steps in software development lifecycle, that's planning, defining, designing, building, testing, and deploying. The importance of software development lifecycle is that it provides a structured approach. It provides a clear framework for software development, ensuring that each stage is completed before moving on to the next. This helps in organizing and managing the development process effectively. It provides high quality software. By following a structured process, software development lifecycle helps in creating software that meets or exceeds user expectations and functions correctly. It is predictable outcomes. With SDLC, you can estimate the time and the cost required to complete the project, making it easier to plan and manage resources. The most important is that it prevents risk management. The SDLC process helps identify potential risks early on, allowing teams to address them before they become major issues. The main objectives of software development lifecycle is that it delivers a high quality software. It ensures that the final software product is of high quality and meets the requirements of the user. It gives efficient resources utilization. How? It uses resources like time, money, and manpower efficiently throughout the project. It gives clear and structured process, provides a clear roadmap for development process. Number 4 is risk management. It identifies and addresses potential risk early in the development process. Number 5 is maintainability. It creates a software that is easy to maintain and update. Number 6 is user satisfaction. It meets or exceeds user expectations. SDLC typically involves 7 key stages. Let's explore each one of them. Stage 1, planning and requirement analysis. Stage 2, defining requirements. Stage 3, design. Stage 4, development. Stage 5, testing. Stage 6, deployment and maintenance. Let's explore each one in detail. Stage 1, planning. First up is planning. This is where we set the foundation. We identify the project goals, create a roadmap, and allocate resources. It's like planning a trip. You decide where you're going, how long it will take. Why is it important? This stage forms the blueprint for entire project. Proper planning and accurate requirement analysis ensures that the project starts on the right foot, setting clear goals and expectations. Key points: gathering information from stakeholders like customers and market surveys. Define what the software needs to achieve. Set up the project's basic structure. Stage 2, requirement analysis. Next is requirement analysis. Here we gather and analyze what the users need from the software. We create detailed documents that outline these requirements. Imagine this as gathering information on what everyone wants for a party, food preferences, guest lists, and so on. Why is it important? The SRS document acts as a detailed guide for the development team, making sure everyone is on the same page about what needs to be built and ensuring the final product meets user needs. The key points about the requirement analysis is it creates a detailed document outlining all the software requirements, gets approval from customers, analysts, and stakeholders, ensures the requirements are clear, detailed, and agreed upon. Stage 3, Design. The stage 3 is the design stage where we create blueprints for software, including its architecture, user interfaces, and data structures. This is like drawing a plan for a house before construction begins. Why is it important? This stage translates the requirement into blueprint for building the software. It involves creating diagrams and models that show how the software will be structured and how different components will interact. Key points about the design stage is that it develops multiple design options. Evaluate designs based on particularity and efficiency. Choose the best design that meets the requirements and is feasible to implement. Stage 4, Implementation. This stage, also known as coding, this, de- this is where developers write the actual code based on the designs. It's like building the house according to the blueprint, turning plans into a working software application. Why is it important? This stage brings the design to life by turning plans into a working software application. It involves writing code using programming languages like C++, Python, or Java, and employing tools like compilers and debuggers. Key points are it follows coding standards and protocols, use appropriate programming language and tools, implement features as per the design specification. Stage 5, Testing. Once coding is done, we move to testing. We check the software for bugs and issues to make sure everything works on as expected. Think of this as inspecting the house for any defects before moving in. Why is it important? Testing helps ensure that the software is reliable and performs as expected. It also involves integrating different parts of the software to make sure they work together smoothly. It conducts various types of testing, for example, unit testing, integration testing, fixed identified bugs and issues, document the software, provide training, and offer support. Stage 6, Deployment. After testing, it's time for deployment. This is where we release the software to users. It's like moving into a new house and letting everyone use it. Finally, we have 7th stage maintenance. Even after deployment, software needs updates and bug fixes. This is like taking care of the house by repairing issues and making improvements over time. Why is this stage important? This stage ensures that the software is successfully implemented in a real world environment and continues to perform well. Regular maintenance keeps the software up to date and functioning smoothly. It helps to release the software in phases if necessary, monitor performances and gather user feedback, provide ongoing support and update to address issues and enhance the software. There are several models used in SDLC, each with a unique approach. The most common ones are waterfall model, V model, iterative model, spiral model, agile model, and Big Bang model. Waterfall model. First up is the waterfall model. This is one of the oldest and the most straightforward models. In the waterfall model, the process is linear and sequential. Each phase must be completed before the next one begins. Why it's good? It's good because it is simple and easy to understand, has clear milestones and deadlines. The challenges faced in waterfall models are that it's not flexible. Changes are difficult to implement once a phase is completed. V model. Next, we have the V model, also known as verification model or validation model. The V model is an extension of waterfall model. It emphasizes testing at each stage of development. The left side of V represents development activities and the right side represents testing activities. Why it's good? It has got structured and disciplined approach, focuses on testing and quality assurance. Challenges faced by V model are like waterfall model, it can be inflexible and not ideal for projects with changing requirements. Iterative model. Moving on to iterative model, this model allows for repeating phases. In the iterative model, development starts with a small set of requirements and iteratively enhances the evolving versions until the complete system is implemented. Each iteration includes planning, design, coding, and testing. Why it's good? It allows for changes and refinements. Each iteration improves the product. Challenges faced by iterative model are it requires good planning and design, can be complex to manage multiple iterations. Spiral model. Now let's talk about the spiral model, which combines iterative development with risk management. The spiral model consists of four main phases: planning, risk analysis, engineering, and evaluation. The process is represented as a spiral with each loop representing a phase of software process. Why it's good? It focuses on risk management, combines the best features of waterfall and iterative models. Challenges faced by spiral model are it can be expensive and complex. It requires expertise in risk analysis. Agile model. One of the most popular models today is the Agile model. The Agile model promotes iterative development where requirements and solutions evolve through collaboration between cross functional teams. Key practices include Scrum, Kanban, and extreme programming. Why it's good? It's flexible and adaptable to changes, encourages collaboration and continuous improvement. Challenges faced by agile model are it requires discipline and self-organizing teams. It can be challenging to scale for a larger projects. Big Bang model. Lastly, we have the Big Bang model. In the Big Bang model, development begins with a little to no planning, and all coding efforts are directed towards building the software. It's often used for small projects or academic purposes. Why it's good? Simple and easy to understand, minimal planning required. Challenges faced are high risk for project failure. It's not suitable for complex or large projects. Let's recap what we studied in SDLC models. We covered waterfall model, which is linear and straightforward. V model, which emphasizes testing at each stage. Iterative model allows for repeating phases. Spiral model combines iterative development with risk management. Agile model promotes flexibility and collaboration. Big Bang model has minimal planning and high risk. Each model has its strengths and weaknesses.